All right, so the next thing we're going to talk about is the modulus function and the graph of the modulus function. So the modulus function definition, the absolute value of x or modulus of x denoted as x with two strokes beside it, one to the left and one to the right. So the absolute value of x or modulus of x denoted by what I just said is defined as the modulus of x is equal to x if x is greater than 0. It is equal to 0 if x is equal to 0. And it is equal to minus x if x is less than 0. So in other words, the modulus function is defined differently for different values of x. For values of x which are greater than 0, the modulus of x is x. If x is equal to 0, the modulus of x is equal to 0. If x is less than 0, the modulus of x is minus x. Now, by definition, the absolute value function or the modulus function is a positive function. This means that it returns positive values only. All right, so that's the definition. Now, here's a note about the graph of the modulus function. This says the graph of the function, the mod of f of x, can be drawn from the graph of y is equal to f of x by reflecting the section of y is equal to f of x below the x-axis to above the x-axis, with the x-axis being the line of reflection. So this is saying that we can get the graph of the mod of f of x from the graph of y is equal to f of x by reflecting the section of the graph of y is equal to f of x that is below the x-axis to above the x-axis, with the x-axis being the line of reflection or the mirror line. Now, the part of the curve y is equal to f of x that is above the x-axis remains unchanged. All right, let's have a look at examples 27 to 29. I'm going to start by doing example 28. Now, in example 28, we're asked to sketch the graph of y is equal to x plus 2, and hence sketch the graph of y is equal to the mod of x plus 2. All right, so what I'll do is that I'll draw the two graphs with different colors. All right. So let me decrease this a little as well. And I'll make the graph of y is equal to x plus 2 a little thinner. So we have y is equal to x plus 2. Now, y is equal to x plus 2 is a linear function, and the graph of a linear function is a straight line. Now, it's something that you should remember from coordinate geometry. Now, only 2 points are needed to draw a straight line. So I can start out by saying, for example, I'm going to select a value of x in the domain of f of x or in the domain of y. So I'm going to might say when x is equal to, let us say, minus 3, y would be equal to minus 3 plus 2, which is minus 1. So when x is equal to minus 3, y is equal to minus 1, and this is 1 point on the graph. But remember, I said we need 2 points to draw a straight line. So let's choose another value of x. I might say when x is equal to, let us say, positive 3. Y would be equal to 3 plus 2, which is 5. And so another point on the line is 3, 5. I would then go to the Cartesian plane and plot both points. Sorry. We have 3, 5. And we have 3, minus 1. 3, 5, and 3, minus 3, minus 1. All right, so let's draw a straight line through our two graphs, our two points. Because remember, the graph of a linear function is a straight line. So this was perfectly done. This is the graph of y is equal to x plus 2. All right, so let's change the color now. We're now going to draw the graph of y is equal to the mod of x plus 2. And that one I'm going to draw red. Now, what they said we should do is that if we have the graph of y is equal to x plus 2, and we want the graph of y is equal to the mod of x plus 2, we must reflect the section of the graph that is below the x-axis to above the x-axis. Now, the one point I know that is below the x-axis is the point minus 3, minus 1. That point is below the x-axis, and I need to reflect it in the line, in the x-axis. So I'm going to reflect it in the x-axis. If I do, the point is going to become minus 3, positive 1. Now, if you reflect a point in the x-axis, the x-coordinate is going to remain the same, and the sign of the y-coordinate changes. So if I reflect minus 3, minus 1 in the x-axis, it's going to become minus 3, positive 1. All right, then starting at the x-axis, I'm going to draw a straight line through that point. Starting at the x-axis, I drew a line straight through that point. Let's hope I don't have any technical issues. All right, that's one half of the graph, and this would be the other half of the graph. And so the red graph, the blue graph was y is equal to x plus 2. The red graph would be y is equal to the mod of x plus 2. So again, if you want to get the graph of y is equal to the mod of x plus 2, from the graph of y is equal to x plus 2, you have to reflect the section of the graph that is below the x-axis to above the x-axis, with the x-axis as being the mirror line or the reflecting line. How would I do that? So I would find all the points that are below the x-axis and get the corresponding point that would be above the x-axis when that point is reflected in the x-axis. Whenever you reflect a point in the x-axis, the x-coordinate remains the same and the sign of the y-coordinate changes. All right, so next I'm going to look at example 27. Now, example 27 is asking us to sketch the graph of y is equal to x, and hence sketch the graph of y is equal to the mod of x. Now, everybody should remember that the graph of y is equal to x is a straight line graph that passes through all points on the graph where x and y have the same value. So it would pass through like 3, 3. It would pass through -3, -3. So I'll say it again. The graph of y is equal to x is a straight line that passes through all points on the graph where x and y have the same value. So we should be able to draw that easily. This is the graph of y is equal to x. Now, we have already identified a point on the graph that is below the x-axis. We have identified the point -3, sorry, -3. Now, if we reflect -3, -3 in the x-axis, it's going to become the point -3, +3. Whenever you reflect a point in the x-axis, the x-coordinate remains the same and the sign of the y-coordinate changes. So a point on the mod of f of x is the point -3, 3. All right, let me just change the color to draw the graph of y is equal to the mod of x. So remember the point, the part of the graph that is above the x-axis remains the same, and the part that is below the x-axis gets reflected above the x-axis. And the graph in red is the graph of y is equal to the mod of x. So again, we can get the graph of y is equal to the mod of x from the graph of y is equal to x by reflecting the section of the graph of y is equal to x that is below the x-axis above the x-axis, with the x-axis being the mirror line. All right, let's have a quick go at example 29. All right, so this is example 29. Now, example 29 is asking us to sketch the graph of y is equal to x squared plus 3x plus 2. By now, we should be familiar with how to sketch a quadratic graph. First of all, we know that the graph is going to be a smile because it's a positive x squared graph. So if the coefficient of x squared is positive, meaning the graph is a positive x squared graph, it is going to be a parabola, which is commonly called a smile. All right, so that's the first thing. We know it's going to be a smile. Let's determine the x-intercepts. Now, the x-intercepts are what we call the roots of the quadratic function, and the x-intercepts are the values of x when y is equal to 0. So when x squared plus 3x plus 2 is equal to 0, if I factorize, I'm going to get x here, 2 here, 1 here, everything being plus. Then I'm going to have x plus 1 is equal to 0, or x plus 2 is equal to 0. So x is equal to -1, or x is equal to -2. All right, so my x-intercepts are -2, 0, which is here, and -1, 0, which is here. I know that the graph is going to cut the y-axis at +2. Positive 2 is the y-intercept. So the graph is going to cut the y-axis here. Another important point, all right, and we could also say that a point over here is also going to be on the graph, and that is because the parabola, which is the graph of a quadratic function, is a symmetrical function. Let's now determine the minimum turning point. And to do that, we have to complete the square of x squared plus 3x plus 2. I'm going to bracket the first part. So I'm going to have x squared plus 2 times 3 over 2x. All I did was multiply and divide 3x by 2 plus 2. Then I'm going to have x squared plus 2 times 3 over 2x plus 9 over 4 minus 9 over 4 plus 2. Bracket all of this. Now, x squared plus 2 times 3 over 2x plus 9 over 4 is actually x plus 3 over 2 all squared minus 9 over 4 plus 2. And this turns out to be x plus 3 over 2 squared minus 9 over 4 plus 8 over 4. 2 is the same as saying 8 over 4. So we end up with x plus 3 over 2 squared minus 1 over 4. Now this is in the form a into x plus h squared plus k. So we can clearly see that h is 3 over 2 and k is minus 4. H is 3 over 2 and k is minus 4. This is important because minus hk is the minimum turning point. So minus h is which is minus 3 over 2, k, which is minus a quarter, is the minimum turning point. So that would put my graph around here. My point, this is the minimum turning point of my graph. All right, so now I can draw the sketch. I can draw the sketch of f of x is equal to f of x is equal to x squared plus 3x plus 2. All right, so the graph would look something like this. Now, to draw the graph of y is equal to the mod of x squared plus 3x plus 2, I'm going to reflect the section of the graph that is below the x-axis above the x-axis. The only point that I have that is below the x-axis is the minimum turning point. When I reflect it above the x-axis, it's going to become that point. So if I reflect this above the x-axis in the line y, the x-axis, which is y is equal to 0, I'm going to get the point minus 3 over 2 positive a quarter. The x-coordinate remains the same, but the sign of the y-coordinate changes. Now let's draw the mod in blue. So the part of the graph that is above the y-axis, the x-axis, sorry, remains the same. That part remains the same. And the part that is below the x-axis will get reflected above the x-axis. And so the blue graph is the graph of y is equal to the mod of x squared plus 3x plus 2. The blue graph is the graph of y is equal to the mod of x squared plus 3x plus 2.